Okay. Power. You're going to study power once again when you study electricity, maybe in grade 10. So ultimately, all powers are same. It's not about whether we are studying power here or power there. So here you are studying power with relation to mechanical energy, because the type of energy that you will be studying is potential energy, kinetic energy. So let's first understand what is power. Power is the rate of, now children will get a little bit confused, so we will understand it properly. The rate of consumption of energy. One way to look at it, don't immediately write, first understand. Another way I can also say is power is the rate of doing work. Right, let us understand what is the difference between these two. On one side I have said it by means of energy, on one side I have said it by means of power is the rate of doing work, or the power is the rate of delivering work. Okay, let's understand it. So first, in order to understand it, let's think of a machine once again. Machine, right? A machine is something that does not create energy, because energy can neither be created nor be destroyed. A machine is only going to convert energy, right? So let's take the example of a drill machine once again. So what happens to a drill machine? A drill machine takes in energy. It takes in energy. What energy does it take? It takes electrical energy. Okay, because when the question for power will come, you have to understand which side they are asking you power. And it delivers mechanical work. Have you understood? It delivers mechanical work. That's when the drill machine is going to turn and is going to drill the wall. It's going to make a hole and everything, right? Now look at the definition of power. Now when this machine is being sold, when this machine, okay, it is the rate of consumption. Let me go a little bit more out here. Rate means to rate. Whenever you listen of the word rate, rate means comparison of two quantities. How does one quantity vary with the variation of another quantity? Out here, we would say power we will define as rate of consumption of energy. So power is energy upon time. And if you look at this side, we will say it is the rate of doing work. Power is work done by time. Have you understood? Energy and work both have the same unit. What is the unit? Joule. And the unit for time is second. This is joule and this is second. So then power is called 1 watt, named after the British scientist James Watt. Okay, 1 watt. So we say define 1 watt of power. 1 watt is said to be the power consumed when energy of 1 joule is consumed in a time of 1 second. If there is some machine which is consuming 1 joule of energy per second, we say that the power of the machine is 1 watt. 1 watt is said to be the power delivered by a machine, or the work done by a machine or by a body when it delivers a work of 1 joule in a time of 1 second. Now we need to get our things clear how the question is to be interpreted. Now let's take a drill machine. A drill machine takes in electrical energy and delivers mechanical work, right? Now there are suppose 2 drill machines available at Amazon. There is a drill machine 1 and there is a drill machine 2. The drill machine 1 is a 600 watt drill machine and the drill machine 2 is a 1000 watt or a 1 kW, 1 kilowatt drill machine. Have you understood? Right? Now question arises, suppose our friend Sastra has brought a 600 watt drill machine. You have it. And you are performing some job at your home and you find that you are not very easily able to drill your wall because your wall is rock hard enough. And you get to know that Jaideep sir has got a 1000 watt drill machine. Let me get the 1000 watt drill machine. Now what prompts you to get the 1000 watt drill machine? Because you say, iska power zyada hai. It has more power. So it has more power means there are 2 things. You are borrowing it from me, thinking about this side, that it will deliver more mechanical work in less time. What is the relation of power? Power is equal to work done by time taken. If the power of my machine is more, that means it must be delivering more work in less time. So if you take this machine from me, maybe you will be able to drill the wall much more faster and quicker. And if you see your drill machine consumes less power. That means, or delivers less work. That means your drill machine will be doing the same work in more amount of time, right? Sometimes we say, hey, go and hire this maid. She's more powerful in her work. Means she can do the same job in less amount of time. What you are also forgetting in this case is that if you take Jaideep sir's machine, because the machine does not have any energy, Jaideep sir's machine is also going to consume more energy. वो ज़्यादा work करेगा कहाँ से? ज़्यादा energy consume करेगा. So the 1000-watt drill machine will be more costly for you to operate, but you are still ready for it because the comfort is more. लेकिन 600-watt drill machine आपको क्या करेगा? The effort will be much less. Right? Kirtan, what is the difference between a 1000-watt drill machine and a 600-watt drill machine? No, explain me.
The number of watts is higher.
That I also know. Any kid knows that the watt is higher. You should by now think, why did I ask you this question? Because for last 2.5 minutes, you tried to arrange something below your table. Then you have been fiddling. Then your eyes are not on the screen. You are looking down. You're on this side. Can you explain me what is the difference between a 600-watt and a 1000-watt drill machine? Don't tell me this is 1000 and this is 600. No, I've been talking some donkey statements for last 2 minutes. Can you just narrate one donkey statement out from there? Why I'm saying that I'm saying donkey statement? Because you don't seem to pay any attention to what I'm speaking, which means that I'm talking something BS or some donkey words, right? So can you refer one donkey word that I was speaking, some donkey terms? Tell me, try. Give your best effort. What example was I citing? Can you just come back to the example? That is the guts you guys have in this generation. Had I been in your place, what I would have done by now, you know. So sorry, I was not paying attention. I won't do that again. But you will not surrender. No, you openly say that you were not paying attention. Not okay. Sir, I was not paying attention.
Yeah, I was not paying attention.
So whose fault is it? Is it yours or mine?
Mine.
Then if you don't pay attention, then why join the class? Watch the recording later. Because the way you are behaving in the class is actually disturbing me. Because you are not paying attention. And then it feels that as if I am doing some nonsense talk out here. Okay. Anyways. That's the reason I want you in front of me in the class. And you're paying more importance to your fine arts class of music that you are staying at your home. I'm somehow not comfortable with that at all. And I'm going to speak with your mom on this. Because when you're at home, you're not paying attention. You're not paying attention. That is not done. You may score good marks, but that's not the way. Anyways, let's not lose our temper. So look, so if you hire this machine, the good part is that it will do the work quicker, but it is going to consume more power. Now let us go to our real life scenario. Both these machines are on sale on Amazon. Okay. Now if you see on Amazon, they will always advertise the machine with the watt. A company like Bosch or Black & Decker, 600 watts, and they will say 1000 watts. My question now is, you may be able to answer or not, what is that watt they are mentioning in the website of Amazon or on the box of the drill machine? No, that's understood. As power, by now you should understand that you should relate power in two manners. One is, how much work does the machine deliver for me? Another is, how much energy does the machine consume? Please understand, how much work does the machine deliver? That is also power. How much energy does the machine consume? My question is, when this is stamped on the box of that drill machine, what is it referring to? ये आना चाहिए ना, तभी तो हम सीखेंगे. Suppose you buy a mixer grinder, we buy a mixie. The mixie will be written what? 440 watts mixie. And our friend Nidhi has got 800 watt butterfly mixie. So we get to know 800 watt means the batter will be much more faster, smoother, good. लेकिन what they are trying to mention?
Energy consumed.
Consumed. No one can measure this side. You can't measure this side. This is measurable. How to measure it? Connect the mixie and see the meter reading. You've got an energy meter. We have an energy meter on our, what do you call this, inverter. That small device is the energy meter. It will tell you how much energy. So please, when you are going and buying it and you say, you know, sir, I brought the mixie which is 1000 watt, please be ready to shell out more money also, because this 1000 watt means how much of energy is the mixer grinder going to consume. But it is a thumb rule that if you consume, this fellow cannot store energy. If this fellow consumes energy, this fellow has to puke out the energy also. It pukes out in terms of work. So if you are consuming 1000, you will puke also more. If you consume 600, you will puke less. So ये तो पता चल गया कि 1000 watt का drill machine will do more work. But we don't know exactly what will be the measurement out here unless we have got data with us. But this data is easy to measure. Now the question arises, if a machine eats, what does 1000 watt means? 1000 watt machine means in 1 second, this is going to eat how much? 1000 joules. Will it deliver 1000 joules? Never. No machine can deliver the same amount of power. This is your input power. This is your output power. There will be some power loss out here. Sound karega machine, heat ho jayega. Those are loss, na? Power means energy per unit time. So if you are actually, suppose if you are running this machine for 5 seconds, a drill machine on one go, how much does it run? 7-8 seconds. So for 8 seconds, if you have consumed 1000 joules, you will be giving something like 900 joules. 100 joules to sound, spark, heat hoke bhi barbad hoga. So when you do questions, be very careful which side power is asked and what not. So sometimes they will bring a new factor here called efficiency. Efficiency. Efficiency is denoted by the Greek word like this. N ko lamba karke likhte hain. It is called eta. Just like rho stands for. Efficiency is given by whatever is the output you are getting divided by input into 100%. Did you understand? Output over input. Oh, yeah, output over input. The same as marks scored over total marks. Yield jaisa cheez hai. So now suppose I tell you, now look at me. I tell you, I have a drill machine which is 90% efficient. Will it consume 1000 watt? Yes. How much work will it deliver? 900 watts only it will deliver. In terms of joules, 1000 joules piyega, 900 joule ka kaam karega. And I have another drill machine in the market whose efficiency is 80%. That is also a 1000 watt drill machine. Now you tell me which product will be priced more in the market? 90% will be priced more because its engineering technology is better. 80% का दाम कम होगा क्योंकि 80% पिएगा एनर्जी उतना ही लेकिन काम कम करेगा, गर्म हो जाएगा, right? गर्र करेगा. And 80% efficient means more efficient a machine is, more quickly the hole will be made. Obviously, we will be spending more energy also, right? One tube light in my house, 40 watts. Out here, 5 tube lights, 200 watts. Understood? They are consuming more energy. Are they giving me 200 watts worth of light energy? Maybe not. Because if I touch them, they are a little bit warm right now. Which means thoda sa to heat dissipation hua hai. But we say they are much more efficient than bulbs. Because the bulbs will be becoming much more hot. I don't want heat energy. I want light energy. So this is a much more efficient system. That's why they say go for LEDs. LEDs will have, if you see an LED, like these LEDs are only 3 watt, 003 in computer language. This is 40 watts. Have you understood now? So whenever we do problems on power, we need to understand they are asking us the power of the machine or the power developed or the power delivered. In either ways, we should be able to calculate energy and time or work and time. And to make the problem little bit more complicated, they may introduce efficiency also. Like suppose they tell me what is the power out here. They will tell me what is the power out here. And they will tell the efficiency of the machine. So they will say how much is the power consumption. At that time, instead of multiplying with efficiency, we'll divide by efficiency because we need to find out the input power. Input power निकालने के लिए efficiency नीचे आएगा. Clear हुआ है? So if somebody says define 1 watt of power, 1 watt of power when 1 joule of work is delivered by a body in 1 second. 1 watt of power when 1 joule energy is consumed in 1 second. All the devices that we get, suppose we have, for example, I have a television, a 42-inch television, and it says the power consumption of the television is how much? 110 watts, means it will be consuming electric energy at 110 watts, the rate of 110. Every 1 second, 110 joules taken away. Are we fine with this? And one more concept we have to study, then rest we will be all okay. So have you understood power? Power tells us what is the rate of doing work or what is the rate of consumption of energy. If you are cost sensitive, which we all should be, then we should monitor this, right? If we want to check whether our investment has been good or not, monitor this. End of the day. So sometimes they will tell you a microwave, we have got a Bajaj microwave which is 2000 watts. Don't think that it is going to make your cake or pizza quickly. It consumes 2000 watts. Now it depends upon the efficiency of the machine, how much of those energy it is converting to heat. Because end of the day it is eating what? Electrical energy. और अगर गर्म होने में टाइम लग रहा है तो फिर फालतू मशीन है, आप पैसा ज्यादा दे रहे हो. So whenever you buy a thing, the sticker or the maker's name tells you how costly it will be on your pocket. ठीक है? आई. Anyone, any question here on power? Problems करेंगे और clear होते जाएंगे हम लोग. ठीक है? चलो. Now, another part that you should know, I think it is there because I saw some energy meter drawings. Energy meter है ना? Unit of energy, commercial unit of energy. Okay. The next thing is we should know is energy. Again, back to energy. Beta, what is the unit of energy? The SI unit. SI unit is joules. Okay. Right. Now, say suppose this is our home. This is our home, and in our home we have lot of electrical, not lot, every appliance is an electrical appliance, yes or no, right? There's electrical appliances, and all these electrical appliances are going to what? Consume electrical energy. Do you agree? Now, if they are consuming electrical energy, now they are consuming, this electricity is coming to your house from a body called, we call it DISCOM, the distribution company. Okay, in our case, like the Telangana Electrical Distribution Company, they are distributing us. So obviously you have to pay also. Yes or no? You have to pay, and this pay in our crude language we say a type of utility bill. So what is your utility? Your utilities are gas, electricity, and water. We are talking about electricity out here. So you have to pay. Have you understood this concept? Obviously, you're consuming electricity, you have to pay electricity. Now, when you buy milk, how do you pay milk? By the liters that you consume. 2 liters, 3 liters, 4 liters. Now, question arises, how is the electricity charged to us, right? So obviously, what are you taking? You're taking electrical energy. So the first thought that comes in our mind, that this consumption of electrical energy must be measured in joules, okay? Because joules is the unit of energy, but this is not the case. It is not measured in joules. This typical item is known as commercial. Commercial matlab wherever money comes into picture. Commercial unit of energy. Okay. Usually, what is the unit of energy? Joules. Now we are going to talk about commercial unit of energy. Commercial unit of energy means what is the unit of energy on which we are built. So if you see two people in your apartment, maybe your parents or anyone, after they put you in the bus, they keep on chattering, hey, you know, this month the AC is running so much, itna zyada electricity bill aaya hai. This is a common talk. So they must be saying, yeah, we to consume something like 5,000 units. They keep on saying units, right? 5,000 units. So is mahina bill bahut zyada aaya. This unit, which a common man keeps on blubbering, which a common man keeps on saying, is nothing but the commercial unit of energy. This is nothing but the commercial unit of energy. A common man calls it as a unit. And today, as in we are in Telangana, 1 unit of energy is costing us roughly around 8 rupees. How much? 8 rupees per unit of energy. So if this house would have consumed, say, 5,000 units of energy in a month, which is very, very high, electricity bill will come how much? 40,000 rupees. है ना? तो 5,000 बहुत ज़्यादा होता है, 500 यूनिट कर देते हैं, 8 5 are 40, 4,000 rupees will come. Our job here is to study what is this unit. समझ में आया? This unit is not joule. And is it, sir, used any other place? No, no other place. It is used in only one place whenever you are putting money and energy. Sir, is it happening in India? No. Any country in the world you go, the commercial unit of energy is always the same. Now let's see what is the commercial unit of energy. The commercial unit of energy worldwide is kilowatt hour. अजीबोगरीब चीज है देखो, kilowatt hour denoted by K in small, W in capital, H in small, kWh. So first thing that we should console ourselves is, sir, does kilowatt hour exactly measure energy? Unit से check करते हैं पहले, आ जाओ. Kilo is nothing but a scalar which is 1000, right? Watt, 1000 watt into hour, यही तो है kilowatt hour, right? Very good. 1000 को 1000 ही रखा, watt बोले तो कितना बेटा? 1 joule over 1 second. Agreed? And hour को लिखेंगे तो क्या लिखेंगे? 3600 seconds. समझ में आया? Second ने second को काट लिया. So what do you get? 3.6 into 10 to the power 6 joule. Yes, our theory is correct. It is measuring energy only, but a huge quantity of energy. Imagine, remember mole? It doesn't make sense in saying 1 atom, 2 atom, because when you pick up this much of silver, so many atoms will be there. Can you say 4,63,986.2? No, 1 mole. So many joules. So now go back to these two ladies who were having a conversation. This lady was saying how much energy did she consume over the whole month? 500 units. Means 500 into 3.6 into 10 to the power 6 joules. So if we would have given her an electricity bill, suppose how will an electricity bill come? You will just think on your own. How does our electricity bill look like? Even like in Pebble City, you can ask your mama to show you the electricity bill on my gate. It will have something called OMR, opening meter reading on the start of the month. So opening meter reading was, say, suppose 2645. Then there will be a reading called CMR, closing meter reading, as on the end day of the month, 3645. Then it will be units billed. How much? 1000 units will be billed to you. Have you understood this? It's easy. Now the final bill will be at the rate of 8 rupees. So bill आसान हो गया, easy हो गया bill. यही अगर आपको मैं joules में देता, you yourself will say, अरे निधि last month burned electricity worth 500 into 3.6 into 10 to the power 8 joules. The calculation doesn't look good. So this conversion also you should know that what is 1 kilowatt hour, how to convert 1 kilowatt. First of all, kilowatt hour, does it सुनने से लगता है kilowatt hour is power. No. What is power? एक और hour से multiply कर दिया ना. That means it has become energy again. Just think. What is power? Power is equal to energy upon time. And this is what? आपने एक hour रखा है, means you are again multiplying it with time. So you multiply this also with time. So it actually means energy only. So if they ask you to convert, so do you know how to convert 1 kilowatt hour? 1 kilowatt, kilo means this is kilo, this stands for watt, this stands for hour. So 1 kilowatt hour is 3.6 into 10 to the power 6 joules. Understood? Now see the worst part also. You should know that also. Can I rub this? Okay, one crude example which will actually make you get more vigilant with your appliance usage. So say suppose Sahasra's household consumes 400 units. This is the layman's word. So what will we say? The Sahasra's house consumed 400 kilowatt hour of energy during the month of August. Understood? During this month of August, it must be possible that many times you lost power also and DG power came. You don't get to know. You still keep listening to music, or you still run the AC, or you must be making your very famous coconut chutney, or you must be washing clothes in a washing machine. Let's say 10% is DG power. 10% is DG power, right? In Pebble, we don't get to know now whether it's DG or. So then we say that from the DISCOM, that is from the Telangana board, you drew how much? You drew 360 kWh, and the DG you drew 40 kWh. Are you fine with this calculation? Children, be very, very careful here. ये जो आप DG चलते हैं, whenever the DG is running, the first job is get up and switch off the AC, because now you will get the shocker of your life. While Telangana government bills you roughly at around 8 rupees, the DG power will be something like 48 rupees per unit. So although the chutney is very tasty, it is being made at ITC Kakatia rate. Are you getting it? You might be ironing clothes early morning. Now just see out here. A iron that you use, this is the iron that we are using. Roughly every iron is 1000 to 1500 watts is the power of this iron. Means what? ये iron को हम 1000 मान के चलते हैं. And let's say our Nidhi is a lazy fellow. She takes 1 hour to iron her clothes. 1000 watt device running for 1 hour pulls how much? 1000 watts means this is equal to 1 kilowatt, right? 1000 watts means 1 kilowatt running for 1 hour. So our friend Nidhi has actually consumed 1 unit in ironing her clothes for 1 hour. 1 unit consume कर लिया उसने. ऐसा वो क्या करती है? रोज 30 दिन यही उसका नाटक है. So she is consuming how much? 30 kWh just for ironing her clothes every day morning. And if it was that there was no power outbreak, she is going to pay how much? 240 rupees. But if there are power outbreaks, how much is she paying? कभी-कभी होता है ना, morning को power चला जाता है. That time you should, if that is a thing, have the habit of ironing your clothes the night before. You are spending 48 rupees per unit. So tonight go back and ask, if you are in Pebble, your parent to show you the MyGate bill. And in that MyGate bill, I can show you mine. Okay, I'll just read it. Look how it shows. It's very interesting. Okay, so go to community, go to society dues. Okay, paid, receipt. Okay, let's see online. Yeah, this is the utility bill. Okay, look at my electricity charges. My electricity charges consumption has come 524.55 units. How much? 524.55, and our meters record both the consumption separately. This is Telangana consumption, and that has been multiplied by 7.9 rupees. So my bill has come 4,143. This is for what? For Telangana power consumed. Now during the month there were a lot of power outage also. So let's look at DG. So DG charges, I consumed 3.52 units of DG only. So whenever the DG starts on, make sure if you are running washing machine and all, just shut them. And you know, this month the DG has been charged to us at 32 rupees 65 paisa. I have seen when it has gone up to 48 rupees also. If there are more people, the charge comes down. But if the number of people are less, the DG charge is high. So DG mein chutney bana rahe ho. Get the idea? Anything else you would like to know about commercial unit of power? A commercial unit of power is kWh, and kWh is calculated based on, even in the chapter of electricity, this will come. And then they will give you, there is a bulb, there is this, what is the consumption? Like for example, let's look at this room right now. We got 5 tube lights of 40 watts, 200 watts. Then this television is running, some another 150, 120 watts. Actually, to run the class, my current output is 460 watts. That's like half kilowatt. So if I take a 1 hour class, I am getting how much build? Half unit. Half unit. 2 hour class means 1 unit. So 4 hour class means 2 units. 30 days means 60 units. 60 units multiplied with 7 rupees or 8 rupees, thinking that there is no power failure. But if the power fails, then the DG comes, then you will be paying for the DG rates for these things. Clear now? Let's now do your worksheets. Check. Okay? Okay. Are the worksheets in soft copy? Yeah. So then you can please upload or put up on Skype. I'll ask that Nidhi or anyone who is having the worksheet in soft. Ahiri, you have it in soft? School worksheet? Or you can send it on Skype and class forum, then Kirtan can also have a look. They both dropped off the call.
Sir, can you hear me?
Yeah, I can hear you loud and clear.
Sir, but should you?
I've asked, Ahiri is doing it, don't worry. You have sent one, na? Yeah, you can send the marking scheme also. Kirtan, just check. Sasra is sending some worksheet with the marking scheme also. We'll do the questions from there. Whichever you have sent, we'll do from there. What happened, Nidhi? You're getting dropped so frequently. There's power failure or what?
Oh, my laptop, it's shutting down running there. Wait. That's all.
Apple means throw it in Piramchero Lake. हाँ बोलिए करते हैं. Let's do anything. It's with energy or it's with power. Let's do it. Everything combined, no problem. Okay, on a graph, draw extension of spring based on Hooke's law. Will you be able to draw that? You all know that first of all there will be a linear, and after that it will no more be in linear. Only till the linear portion, Hooke's law is F equal to Kx, the straight one. So what do we show? We show applied load versus extension. Applied load versus extension. So up till the Hooke's limit, it will be a linear, and after that it will no more be linear. घूम जाएगा वहां पे. So this is fine. Numerical करते हैं. आइए. And even I had uploaded a lot of questions for numerical also on Hooke's law and these things we can do there. Yeah. Plus let's do the school part. Okay. 1 minute. A modern train. Okay. The question is like this. What is the question number, Bitu? 1B. Okay. A modern train. So you have a modern train. The train is like this. And the train is approaching a buffer. You know what is a buffer? Buffers are the springs like this, where the train will go and just dram karke lag jayega. Okay? So go ahead. A modern train is the train is having a mass of 2.5 kg. Okay, the energy stored in spring, how much is it? 0.48 joules. After the train has stopped, means try to understand, if the train stops, the train is going to hit the buffer and compress the buffer. Only when it compresses the buffer, you get what energy? Strain energy, elastic potential energy, because you have constrained it. ये buffer कैसा है बेटा? Buffer is something like this. This is the buffer, right? And then the train has come and the train has compressed the buffer now. अभी buffer ऐसा हो गया है, train यहाँ पे आ गया. This is the train, है ना? So definitely some bit of compression must have happened. There is a compression which has happened. Agreed? Yeah. Calculate the initial speed of the train. We have to calculate what is the speed of the train. Okay, what was the initial speed of the train? Now understand one thing. Was the train moving initially? If the train is moving, does it have any form of energy? Kinetic energy. So the train has got kinetic energy with it, and the value of the kinetic energy is given by half mv square. The train stopped. So what is the kinetic energy? V became 0, kinetic energy became 0. Where did the kinetic energy go? To Sahasra's house? No. Energy can neither be created nor be destroyed. But we think that there is a 100% perfect conversion. Otherwise, there would have been heating will also take place. So this kinetic energy is nothing but which has got converted and got stored in the spring. Now, can you calculate the velocity? करो फिर. All of you understood? Ashmita, ये problem समझ में आया आपको?
Yes, sir.
Are you with the question paper with Sahasra? It is your school question paper only.
Yes, sir. I don't remember this one.
हाँ, जो भी है ऑनलाइन या प्रिंटेड जो भी है आपको आखिरी समझ में आया. Train was moving. A moving train has kinetic energy. That kinetic energy got converted into what? Elastic potential energy and got stored in the buffer spring. Are we fine, bachcha log? Now find out the velocity and do make sure of significant figures. The way you should always report it in the least significant figure amongst all given values. क्या रे आखिरी हो रहा है कि नहीं? Half mv square is equal to the energy stored in the spring. How much did you get? Kirtan, able to understand this?
Yeah.
V equal to how much did you get? 0.62 what? Meters per second. Did everyone get this answer?
Can you show us how to solve it?
How to solve it? The kinetic energy of the is how much? Half mv square. This should be the energy stored in the spring for it. So this becomes how much? 0.96. And then v square is equal to 0.96 divided by 2.5. So v is equal to root of 0.96 divided by 2.5.
Okay, sir. Let's say V is the final velocity. And then
V is the velocity of the vehicle.
O Z is 0. It's fine.
जीरो होने से काइनेटिक एनर्जी कहाँ आएगा?
Okay, yes, sir.
जीरो जब हुआ तो उसने अपना काइनेटिक एनर्जी दे दिया ना किसी को.
Yeah. Okay, sir. That's a very good one. Thank you, sir.
इसमें ज्यादा ध्यान कम दो बिट्टू, ये समझने में ज्यादा ध्यान दो कैसे हुआ. ठीक है, चले आगे. All of you got the answer? Nidhi got the answer? Okay, let's go ahead. Next 1C क्या है? Sasra? Okay, there's no 1C, so we're done. Go ahead. Okay, that means I'm on question number what, beta? Question 2, A, B, C, D. A. So the figure shows a conveyor belt. So this is like a conveyor belt which is sending everything to a raised platform. Okay, I'm drawing the figure to my liking because I don't have it. I'm listening from her and drawing. Okay,
mass of the package.
Okay, the belt is driven by a motor. So a motor is driving the belt. Okay, and there is a package. So I have a package. What is the mass? 36 kg. 36 kg is the mass of this package.
Increase in gravitational potential.
Calculate the increase in gravitational potential energy. So obviously it is understood that this is the initial point from where the lift is happening, right? And this is the final point. But remember, the increase in gravitational potential energy, GPE, is always equal to mgh. This h is nothing but this h. How much is the height? 2.4 meters. ये understanding important है. ऐसा क्यों है? आप सोचो. How did we get this formula? We have to lift it with a force mg and h. And whenever we are doing work is energy. Work में force और displacement same direction में होना है. इसीलिए बच्चा ये वाला direction, if it is given to you also, just ignore it. ये height is what is matters to us. So in the question, is it mentioned that the height platform is at this much height? Yeah. So now can you do it? Take the, since you are using calculators, you can take this value as 9.8 meter per second square. Can you get the value? And let me know. Ketan darling, understood this one?
Yes.
Yes, sir. Somehow I have to get to his house and steal those drumsticks. Entire problem will be solved. Hey Nidhi, you fought with somebody in Pebble City?
No, disease or
Okay. So when will you learn driving? How many more years to go?
I don't know, maybe around 20.
Hey, 20. The day you all become 18, first learn to drive. Don't ever have that fear getting inside you. I thought you fought with somebody out here and that girl must be waiting at the gate every day.
No, I think
With nails. कितना आया बेटो? 8? 846.72. What? Joules. एनर्जी कैलकुलेट कर रहे हो, देखो. ठीक है? Has anyone got this answer? I mean, after having calculator also, why do you all have so much traces of doubt on your face? हाथ में calculator है. If somebody would have given me a calculator, I'm ready to do any problem. क्या मुश्किल है? But did others, anyone, someone has to support? You got the same answer, तो फिर ठीक है. आइए चलिए आगे चलते हैं. क्वेश्चन नंबर क्या हो गया बिट्टू? बी. ओके, बी चलो. Okay, calculate the power. Now the second one, we have to answer power. And whenever power comes to your mind, what is the definition? यहाँ पे energy बोलेंगे, energy per unit time. तो energy तो हमें मिल गया था. What was the energy? The gravitational potential energy. Time we need in this question, have the specified time 4.4 seconds. So find out इतना watt आएगा आपका. 840 something was there, na? You found out, right?
it's like 192.4
192.4 watts. ठीक है, दो आदमियों को आ गया तो ठीक ही है आंसर. 192.4 watts. ठीक है, आगे बढ़े. All of you understood this? Power from energy. Okay, चलिए. Next. C है क्या बिट्टू अभी? Okay. Now see the interesting thing. One minute. So we have, let me do the question now. We have a motor. right? The question is to be understood like this. The motor is connected to electricity. That means the motor has some power rating. Yes or no? This power rating refers to what? Always this, what it is going to consume. And the motor was capable to lift package. That means this is work done. And you did calculate what was the gravitational potential energy, and you also calculated what is the power. This power was actually the work done, time taken. ठीक है ना? ये आगे आप question पढ़िए. The motor is connected to electricity. I explain how conservation of energy takes place. So what happens? The motor consumes electrical energy, and assuming that the efficiency of the motor is 100%, the motor converts the entire electrical energy into mechanical energy. That mechanical. So first of all, what is happening? Electrical energy is being converted to mechanical energy. Who is converting it, beta? The motor is converting it, and the motor is converting into mechanical energy. That means this is the belt. Belt ka jo movement ho raha hai. And the belt is finally converting the mechanical energy into what? Gravitational potential energy. Now, as a student of science, you start thinking there will be a loss here. There will be frictional wear and tear loss out here. So ultimately, the gravitational potential energy developed by the package when it goes up, if everything was fine, then the package when it went up, does it have energy? Yes, it has energy, because if I put it on Nidhi's face now, it will cause injury. Yes or no? It is energized. This energy should have been exactly equal to the energy it consumed from the power socket. So how do you explain? Electrical energy is converted to mechanical energy, and mechanical energy is being converted to gravitational potential energy. And assuming that there are no losses in any of the conversion stage, the law of conservation of energy is satisfied. In reality, there will be some losses, but if the losses happen also, then also conservation of law of energy is, because we will say the net of the electric energy should be equal to the sum of mechanical energy plus some losses plus GPE plus some losses. ये diagram आपका match करेगा ही करेगा. This mathematics has to match. If the machines systems were ideal, losses would be zero and they would be equal to this. Understood now? Sankey diagram था ना आपके book में कुछ. If you see, there is a thing called Sankey diagram in your book. Every stage they will show from the boiler how energy is being lost. Just see, there is a Sankey diagram. Block arrows. Yeah, that's the Sankey diagram. That one. नीचे देखो क्या लिखा है? Sankey diagram. A Sankey diagram is a representation. Read what is there. Read the pink blocks. Energy from the chemical energy input is 100%. So here electrical energy input is 100%. Then it goes into a boiler. It goes into a motor. Thermal energy is transferred. Mechanical energy is transferred. नीचे loss जाएगा आपका. समझ में आ गया? वही वाला चीज है ये. Okay, let's take the next one. Chalo. Tomorrow we will target pressure. ठीक है? And then we still have 1 week for any revision if you want. तो डरने की कोई बात नहीं है. चलो, बोलो बेटा. Assume that the power available to raise is constant. The power available is constant. ठीक है? Okay, then 1 minute. You have a package whose mass is now how much? Greater than 36 kg. Raised to the same height? Okay, it is raised through a height of how much? 2.5 meters. Okay. 2.4 meters. Okay.
Is this how they affect the mass?
Will affect in the operation. Okay. Now come here, children. Now the mass is greater than 36 kg. Do you agree? You have to lift it through the same height of 2.4 meters. Don't you think that the GPE Once you have lifted, it will be more mass into height. If the GPE is more, that means the mechanical energy should also go up. If the GPE has to go up, the mechanical energy has to go up. But my motor never manufactures mechanical energy. Motor only converts electrical energy. So don't you think that the electrical energy consumption will automatically go up? Yes. So my dear friend, if you are grinding an onion, then it doesn't cost you on your pocket. But if you are making urad dal batter, which is very, very tough, you must have made urad dal batter, it's very tough. So kinetic energy zyada chahiye. So the machine also makes a lot of noise. Sometimes when people make dosa batter in mixer grinder, it is and it stops. Then you have to tilt the machine and again press the reset button because you have overloaded the machine. ऐसा मत सोचो, power is available, but is this particular motor able to do this work or not? So that also we should see. So if power is constant, if the power is constant, then the motor will start heating up. Now they say that the power is constant. You can't draw more power. See, in this case, if the GPE goes up, the mechanical energy demand goes up. If the mechanical energy demand goes up, the electrical energy demand goes up. If the electrical energy demand goes up, then your input power demand also goes up. But the question has put a restriction on input power is constant. So what will happen? It will be difficult to lift it. The motor will burn out. Constant है ना? It needs more. ऐसा साउंड करेगा और फिर आप फिर भी उसको दबाए जा रहे हो, नहीं जाएगा. That is the same.
More time, right, sir? So let's just more.
कौन सा?
Let's say if the master it will take more time to make.
It will take more time. Yeah, it will take more time now. They will say more time as the answer.
Increase in potential that's what the mass is greater. The work done energy goes to its mass is greater.
And if the power is constant, see, like this, power is equal to what, beta? Work done by time. You have made this as constant. You have made this as constant. And now you are increasing the work demand. So the time is, इसको बढ़ा दिए हो, इसको constant रखे हो, इसको बढ़ाने से भी ये भी बढ़ जाएगा ना. To keep the ratio. Time taken is P is reduced. We can't say P reduced because they have said the power. Speed is reduced. Yeah, speed will be reduced. Time taken is longer, and not only that, in the longer run, the machine will conquer. That's why every machine has a rated power. You should not do the work beyond that power. For example, if the drill machine is rated for 1000, don't take it outside and start drilling roads. सब कर देगा. That idea will not work. कर देगा. ठीक है? अभी देखो एक बढ़िया सा एग्जांपल देता हूं. Like say the inverter that we have now in our house. Okay, our inverter as per the manufacturer can take say 900, but they will say peak power is 786. ये peak, ये rated you should never go for. Our daughter is very good. That is rated perception. Actually daughter हल्ला गुल्ला करती है, so actual will be less. So whatever load I am putting on this inverter should be less than this. If I increase more than this, वो heat up होना शुरू हो जाएगा और फट करके फट जाएगा कभी ना कभी. ठीक है, चलिए next question. What 64 kg? An athlete. Okay, we have an athlete. So we have an athlete. Very good. बोलिए. Okay, his mass is how much? 64 kg, and he is bouncing up and down on a trampoline. Very good. Once again, you went slow on your reading. No, come again with the question. An athlete of mass 64 kg is jumping up and down on a trampoline. Stretch surface. So at one moment, the athlete is stationary on the stretch surface. Okay, fine. State the form of energy. इलास्टिक वो उसको आप स्ट्रेन एनर्जी बोलते हैं आपके बुक में, सो दैट्स फाइन. Stretch surface of the trampoline. So the trampoline has now stretched and now it again begins to contract, means it is going upwards. Okay. The athlete is pushed vertically upwards and there is an acceleration. Okay, fine. At t time, the upward velocity is how much? 6.0 meters per second. She loses contact with the surface. Okay. Calculate her energy at time t. क्या है इसमें? Half mv square. Her energy would be, she's in motion. All energy is kinetic energy. करके देख लो आंसर. Half mv square. इसको कैलकुलेटर क्या मारते हो रे? हर चीज में कैलकुलेटर. 64 into 36. Oh, sorry. 18. 64 into 18. Or check your answer. Oh, marking scheme देख लो. I have also given you some more worksheets भी है. करते रहो, जितना करोगे उतना क्लियर होते रहता है. There can be some issues. There's no other data, right? She leaves contact, huh? Then there is some misprint. Right. Next question.
Calculate the maximum possible distance.
Maximum possible distance she can travel upwards after time t. Okay, after time. This is a nice question. Now after time t. So at t time, what is her initial velocity is 6.0 meters per second, right? And calculate the maximum possible distance. So what should be the distance? We will take it as the distance is upwards, right? S. Now you can do it in two ways. देखो एक तो ऐसे कर सकते हो. S is equal to ut. Now you are going gravity के against जा रहे हो तो minus half gt square. This is one we can say. ठीक है? Plus v square, or we will not use this one. We will use v square is equal to u square minus 2g, the maximum height that she would go. Minus, because the gravity के against जा रहे हो. And if you want to do it, no sir, I want to do it from the basics. If you want to do it from the basics, very nice. You are going upwards. So the maximum when you go, your final velocity would be what? 0 square, right? Initial velocity is upwards. So initial velocity will be v square equal to u square plus 6 square, right? Plus 2 into a. A means the gravity. Gravity always acts downwards. Into the height you are going, height is going upwards. First. Okay? So this becomes negative 36 is equal to negative 2 into 10 into h. Negative cut. Then 2 cuts it as 18. 18 divided by 10 is 1.8 meters. Considering g as 10, if they do it with 9.8, the answer will be a little bit different. Did you understand this? Anyone who did not understand this part? V square equal to u square plus 2as. Or you can take v square equal to u square minus 2as because you are going against gravity. That's the best way to understand. Against gravity minus, with gravity or say plus. Check करो. थोड़ा confidence आया बेटा? The factor with which you told, sir, will we be able to complete? अभी थोड़ा अच्छा लग रहा है? Right. Hey, what you are pressing calculator? हो तो गया. Why are you pressing calculator? Check कर. उसके लिए कैलकुलेटर मार रहे हो. क्या? बाकी ट्राई करेंगे. हाँ.
In practice, she travels through slightly smaller distance than the distance calculated. Just why is this?
In practice, she will go less. Why? This problem is not taking air resistance into consideration. Here you are not taking air resistance. Air resistance will be there, na? Drag will be there. These formulas work when air resistance is considered as 0, but air resistance will be there. So air resistance will not allow her to go that much up as you will. You thought that it will be 1.8, you will be short of 1.8 because air resistance will be opposing your upward movement. You can write the answer as air resistance. Impact of air resistance or drag. ठीक है?
Jumping springs are being tested and extension load graph is plotted.
Okay, the trampoline is tested on a spring graph and you have plotted a load graph load. Okay, go ahead. No longer linear. That's the point of ultimate stress. After which, there's the Hooke's yield point. Hooke's law is when the extension is proportional to the load applied. So you will get a straight line. The moment you don't get a straight line from that point, क्या हो गया है? Ultimate. इसके बाद और that's the yield point. Beyond that, Hooke's law is not applicable for you. Limit of proportionality. That is the point is known as the limit of proportionality. Hooke's law.
And a rectangular chain is initially just
ये करो खुद करो अभी. Or you want to try? इसका टाइम भी हो गया. Kirtan, what happened? 8 o'clock?
Yes, it comes.
Oh, but I will right click and disconnect you. How can he stay? Rest will you try? Or एक बार try करो घर पे. Have you got a fair bit of idea now? Again, tomorrow we are sitting. Don't worry. Tomorrow we will get inside pressure. So we will have initially some idea, all idea about pressure. Then we'll do problems on pressure. And after tomorrow, your exam still is far away. We have 3 more classes next week. So we go back to quadratic equation, long formula wala, and we will put, if we cover pressure tomorrow, we will put a break on physics till your exam is over and you can dig whatever you want. और mole calculation को रोक के रख रहा हूँ. Tension मत लीजिए. आप exam दे लीजिए. उसके बाद moles फिर आगे जाएगा. So make use of your next 3 classes. But yes, maths we will go ahead. Quadratic equation, that will help you in your exam only. Quadratic equation with the quadratic formula. ठीक है? So our next class will be tomorrow. We are going ahead still with physics and we'll complete pressure. Right, बच्चा?